Okay, I'm going to start out by giving you some information. If you had 5 cubed, it's not going to be a big shock, but if you had 5 cubed, you would say, oh, that's 5 times 5 times 5. And you'd get a calculator or just do it by hand, and you'd get 125. So 5 cubed is 125. Okay, remember that. So now we've been talking about, in this section, square roots so far. That's all we've been talking about. Everything was a square root. Sometimes I use the word radical, but we were just talking about square roots. Now we want to talk about other roots, like a cube root, or a fourth root, or a fifth root. Okay, so other roots can be like a cube root. Maybe I want to take the cubed root of 125. Okay, so this is this part I just told you about. So you can do that. There is a cubed root of 125. It's going to equal 5. Okay, because there's a group of 3 5s that are being multiplied together, but now we need groups of 3 to get one out. Remember when we were doing square roots and we had something like 2 times 2, and I said, oh, there's a pair of 2s, so that can come out. Now it has to be a group of 3 because it's a cubed root. Okay, so what do you think is going to happen if you want a fourth root? Well, you'd have to have a group of 4. So let's look at 16. If you break 16 down into its primes, it turns out it's 2 times 2 times 2 times 2. Okay, so there's a group of 4, so the answer would just be 2. You can take the fourth root of 16. Now there's lots of numbers you can't take the fourth root of, but 16 you can. Okay, so a little bit of terminology. This number here that I'm writing, that 4 and that 3, that's called the index. Okay, now if you just have the radical symbol like that, that is a square root. You don't have to put the little 2. We all know it's a square root. But any other root, like a cubed root, or a fourth root, or a fifth root, you know, and you can just keep going. The nth root they talk about, meaning that n could be any integer, okay? It's a positive integer. Okay. I guess, yeah, I can say that. All right. And you could have the index be any positive integer. Radical, that's the symbol. That's the radical symbol, the little check mark thing. The radicand, which is a fun word, that's the stuff underneath, okay? So when I say, oh, I want to take the cubed root of 27, 27 is the radicand. You don't hear people talk about it a lot, but that's what it's called. Okay, so remember back when we were doing square roots, we said, well, if I have the square root of a squared, we said we have to say that's equal to the absolute value of a. We're not changing that. That's still true. But it's different when you have other powers. So like a cubed root, remember we said, oh, you can't take the square root of a negative number, like you can't take the square root of negative 8, but you can take the cubed root of negative 8. There is a negative number that you could multiply 3 times and get negative 8. It's negative 2. Because negative 2 times negative 2 times negative 2 times negative 2, that is a negative 8. So it makes a difference if the index is odd or if it's even. So if you have some nth power of a to the nth, that's going to be equal to a if n is odd. So see how here I have a negative 2 times a negative 2 times, I have negative 2 cubed? That's how we're getting that negative 8. So it stays true. But if you have the nth root of a to the nth, it's going to equal the absolute value of a if n is even. Just like with the square root, right? Because see, then you'd have a problem. So you couldn't say, like if you wanted to say, what's the fourth root of negative 2 to the fourth power? It's not going to be negative 2, right? because when you multiply negative 2 times negative to the fourth power, you know, negative 2 times negative 2 times negative 2 times negative 2, you're going to get a positive number, and then when you take the fourth root, it's going to be positive. So that's why we have to use absolute value if the index is even. Okay. Now, the product and quotient rules, those just go like we had them before. So remember we had the square root of AB equals the square root of A times the square root of B. Well, you can just put n's in there. You do have to be consistent. It has to be the same index, okay? And then the same thing for if you have the nth root of A divided by B, you can split that up into the nth root of A over the nth root of B, okay? So not too shocking there. All right, so now we want to simplify. They want to know what's the cubed root of 24. Well, I could think and think and think of perfect cubes, or I could just say, well, let me break it down into its prime factorization. Now, when I write a different index, I have to make sure I write that. Like, I can't leave the little 3 off, because then that's a problem, because then it's the square root, right? Okay, so if you break 24 into its primes, 4 times 6, and then 4 is 2 times 2, and 6 is 2 times 3, you'd have 2 times 2 times 2 times 3. So now we have to have groups of 3. Your index will tell you how many you need in the group. So that's a group of 3 2's. I can get those out. And if you don't like doing it that way, you could think, the other way is to think, well, what's a perfect cube that goes into 24? 8. 8 times 3. And then is 24. And then I have to think, well, what's the cubed root of 8? And I'd have to know that, times the cubed root of 3. Okay, now a little bit about writing these. See that little 3 there? That's the index. You have to have it, or the answer is not going to be the same thing. It would say the square root of 3, and that's not the same thing. You have to be careful. I like to put it like inside the check mark, but you'll notice when I'm typing these, it kind of sits on top there. There's really not anything I can do about that. That's the way the font is. So just, just be careful when you're writing them. Okay. So let's do another one. So we have the fourth root of 8 and the fourth root of 4. Okay. I could just multiply them together and say the fourth root of 32. That's true. But then I'd have to break down the 32. So I could say, well, it's 16 times 2, and we already did the 16, so we kind of know the answer. Or I could break the 32 down into all its primes. Like I could have done it here and said 8 is 2 times 2 times 2, and 4 is 2 times 2. So there's like 5 2's. That's what 32 is. It's 5 2's being multiplied together. So you need a group of 4 to get one out, and the other one will have to stay inside. So that's how that simplifies. Okay, so now we have a fourth root. It looks like we have a fraction, but I can split that up and say the fourth root of 81 over the fourth root of 16. I could check to see if that fraction simplifies, but it doesn't, so I'm not going to. 81 is 9 times 9, right? But each 9 is a 3. So it's 4 3's. Now you might just say, oh, I knew the fourth root of 81 was 3. But if you didn't know it, here's the visual for it. There's a group of 4 3's, so that just makes it a 3 in the numerator. Now in the denominator, what's 16? Well, we've done that one a few times. There's some of these get repeated a lot because there aren't a lot of perfect, well, there's a lot of them, but like they get really large. Okay, so 3 over 2 is the answer there. So group of 4 2's in the denominator, and we're getting a 2 out. Okay, so one more problem here. This is a long video. I have 5 times the cubed root of 16 minus 11 times the cubed root of 2. Well, I can't combine them because they're not the same radical. Now, one of the things we have to say is the index has to be the same, or you're never going to be able to add those. But they are both 3, so there's hope. I'm going to have to simplify this 16, which is 8 times 2. Now I know the cubed root of 8. That's a 2. You could do, 16 is 2 times 2 times 2. We've done that one a few times already just in this video. And there's the 2 that you're getting out. minus 11 times the cubed root of 2. I'm not going to do anything there because 2 isn't going to break down. It's just 2. So I have 10 cubed root 2 minus 11 cubed root 2. So now I can combine them because the radical part is the same. All right, so 10 minus 11, that's a negative. You can put a 1, but we don't usually write it. Cubed root 2.